is Amisha Kapoor, and this is my Lab 1 video report. So I would say the general purpose of this lab is to allow for students to not only learn how to appropriately collect data, but also how to produce accurate models and how to apply functions, which they particularly learn through part 2 of the coding section. Through this, I was able to learn how model shapes and charge distributions impact one's calculations, with ones more closely aligned with the shape, um, specifically being the line model in the tape, providing answers of higher accuracy. Additionally, I learned how much one's environment, the level of humidity in this case, can impact experimentation, as it took me a multitude of tries to actually create charged tape, I believe because my environment is too humid, at least initially. The primary principles that I used within this lab are the ideas that opposites attract and like charges repulse, the law that F equals ma, and also the idea that force is equal to charge times the external field around that charge, the external electric field. As for the experiment, my system was tape B, which you can see as the tape on the top, which, as a side note, I charged and obtained tapes by laying one tape on a counter and then ripping another piece of tape off of it. So tape B is my system on the top, and my source is tape A. The software I used is GlowScript, and my knowns are the distance between the tape. Specifically, you can see I calculated that with the ruler in the top left-hand picture. I also found the length of the tape, which I calculated while I was measuring it to put down on the table before I ripped it off. And I got that to be 0.2 meters or 20 centimeters. And because I did not have the means to measure the mass myself, I used the general calculation that clear tape tends to be 1 gram per meter. And so using that information and the length of the tape, I was able to get that the mass of my tape is 2 times 10 to the negative 4 kilograms. And then additionally, using the equation on the bottom right-hand corner, this equation is particularly derived to represent point charges, electric fields, as in the PDF, in the initial version of the experiment, you model everything as a point charge. In doing this, I was able to get that the magnitude of the force of gravity is 0.00196 newtons, which is equal to the magnitude of the electric force. And then lastly, through the general idea that F net is equal to 0, I was able to set up an equation where I could solve for the electric charge being 7 times 10 to the negative 9. Additionally, I had some questions from the PDF that I had to solve. And so the very first question from the PDF is that was to ask for my initial observations as I was going through this lab, and it was the fact that when you put two pieces of tape that have both been charged next to each other, they repulse, which allows you to make the assumption that they have the same charge. And as for the next set of questions, essentially what I did is I took a plastic pen and I rubbed it against my hair, and since we knew that would create a negative charge, by looking at its interaction with the tape, which was also charged, I was able to determine that the tape was in fact a positively charged item. Next, as previously mentioned, I said that F net was 0. This is because of the fact that there is no movement up or down from tape B, essentially meaning that the force of gravity is canceled out by the electric force from particle A or tape A. And so lastly, in order to actually get into my calculations, in order to find my charge by setting up an equation like net force equal to force electric plus force of gravity, and then moving over force of gravity and solving for the charge. In order to do that, um, knowing that the net force is zero, I still had to find my mass. And so, as previously mentioned in the last slide, I found that to be 2 times 10 to the negative 4. Um, next on, um, I found that my force of gravity had a magnitude of 0.00196, but I also found my separation distance, and this happened to be 0.015, the picture for which you saw on the last slide of the method of me finding it with a ruler. Um, lastly, I found that outside of me finding that my charge is 7 times 10 to the negative 9, I also found the amount of electrons present within the tape. And so essentially, and this is based off of me dividing the charge by the electron. So that is like 1.6 times 10 to the negative 19. And this got me 4.375 times e to the 10. And we actually have a deficiency of electrons because we have a positive charge. And then next, by using the length of the tape, I was able to find the ratio of my electron deficiency to atoms in the tape, and I got 21.875. As for the code, this is my first bit of code. It was also modeled using the idea that both pieces of tape were point masses, meaning you had to make the assumption that all of the charge and the mass was compressed into a singular point. Um, Doing this, I was able to find that my charge was 7 times 10 to the negative 9. As a quick run through the code, I put in all of my constants that I had already found. I added a scalar to make the vectors visible. I defined my two objects so you could see them in the visual on the bottom right hand corner. And then I actually took my function that I created in lab 0 and made slight edits to the variable name so I could apply it here. Lastly, using the principle that F equals ma, as previously mentioned, I was able to find the force of gravity, which is equal to F equal mg in the negative y direction. And so I applied this to both A and B, and then using the principle that force equal to charge times its external electric field, I was able to find the force electric on A and the force electric on B, which allowed me to create the representation on the right-hand side. So this is my glow script code for part 2, which is the line model. And so essentially what this involves is, first, if you look on the left-hand side, you see me defining my variables, and I actually got a um, slightly higher value for my net charge. And so essentially, as a quick run through the code, I once again use the same function as before with slight changes in the variable names to adjust to the code. Then I adjusted my Y positions in the line for what top tape equals to and bottom tape equals to. And for clarity reasons, I set my bottom tape to be 0, 0, 0. And then after that, in order to make everything visible, I had a scalar, which was 1 times 10 raised to negative 5.5. And I similarly did the same thing for my force electric and my force of gravity, which actually had a different scalar. And so through this, I was able to get the charge of 7.98862 times 10 to the negative 9. And essentially to do this, I also had to assume that the tape was perfectly straight. There were no environmental factors. Um, And so this is the next part of my glow script code. And so essentially what it involves is actually me calculating what my electric force is on the small charge section on the top based off the charges at the bottom. And so part of that includes um, me taking like the E field at the top and well, for a small section at the top and multiplying it by the charge at the top so I can get the force, which is once again the same principle that I described earlier, that force equals charge by external field. And then since we are doing multiple sections, since this is dq, um, we're essentially adding them all together in my FE on top so I can get the full electric force on the top tape. And then after that, I just created a arrow for my electric field at DQ on the top. And so once again, I put in a scalar to make it visible. And then I put in, since we're representing the electric field, I put in the variable name that holds our electric field value. And then the only other real differences that I made in here is I added a value in FE arrow. And so once again, I added a scalar. And then since we're looking for the electric force, I took the value that represents that, which is FE on top, and I multiplied that in within the axis variable. And then once again, I also found the total gravitational force. And so to do that, I took the m of the entire piece of tape and I multiplied it by gravity. So in general, we had two major what ifs. And so one of them is what if electrons were positively charged and protons were negatively charged? And based off my observations, I would say that it doesn't change anything. And so essentially, all your calculations would remain constant because they're not dependent on whether or not something is a proton or electron. They're dependent on the actual signs of the protons and electrons. So all that's really changing is your verbiage, not the calculations. You get the same things. As long as you maintain the idea that negative is attractive and positive is repulsive, and those ideas, and that opposites attract. If you maintain that, then your calculations will be the same. Next, I was discussing why might my answers for my charge for the second model be different than my answers for the charge for the first model. And I'd say one of the main reasons for that would be the fact that my second model is more accurate in shape to the actual piece of tape. And so additionally, it also calculates at smaller indices, or indices, essentially allowing it to, take account of small um, perturbations, like and different differences with each DQ calculation, since it's going step by step, is kind of similar to the idea. Anyways, so taking this into account, the line model, um, because it's closer to the shape of the actual tape, is more accurate of a model than the point particle. And this is very similar to the idea of like Riemann sums. And the idea that like the more rectangles you have, the more splices you have, um, in this case, the more DQs you have, the more accurate you're getting a reading of whatever you have compared to a point particle, which is just one major reading and kind of almost like averages everything up. Thank you.